Hi, folks, and welcome to Physics with Captain Rod. I'm making this video to help you out with number 8 here on your homework. I think this is in Unit 1-2 here, I believe. Okay, so it says something about traumatic brain injury as a result of a head undergoing acceleration. Now, it's a pretty long paragraph, but the gist of it is basically this. First, it talks about the head of a baby falling a certain distance. So this is some number given in the problem. And if the person's free falling, then their acceleration is what we call g, 9.8 meter per second down. So if we did a velocity graph for that with, let's go ahead and do call down positive, that graph would look something like this. Because as time goes on, the person's going to be moving faster and faster and faster. Now, you don't know the time, and you don't know the final velocity. This ultimately is what you're going to be going after here. These graphs have two equations that come that we can use here. First, the acceleration, which is going to be 9.8 meter per second, right, is equal to rise over run. Now, I don't believe there's enough information here to solve that, so we're going to go on and write another equation. The distance, h, right, is going to be given by this area. That's going to be 1/2 base times height. So this is a number that's given in your homework problem, and this is two equations, two unknowns, 1, 2. So what you can do is something like maybe solve this for v and sub it here and get t, and then go back and get the v. So that's the idea, is you need this to do the second part of the problem. Now, the second part is the baby's head is moving. What we call the final velocity here, we're now going to call an initial velocity here. It comes in contact with the ground. And it still moves down some, but a very small distance. I put a small delta x here. And the velocity graph now is going to look something like this. From some initial velocity to a velocity of 0 when they're stopped. And again, that's an unknown time. So there's two equations we can write here. One is from the acceleration, which is going to be minus v initial over t. That's coming from rise over run. The v initial here is a numerical value here. And then the area gives the distance traveled. So the delta x is going to be 1/2 t times v initial. And this is given in the problem. Now, they actually give you several of them. They give you one for hardwood floor and one for carpeted. But so what you're going to do is, let's see, take the one for hardwood. You have the v initial from before, solve for t, go over here and get the acceleration. So, and then repeat for the carpeted floor. So that's probably enough on number 8. But hopefully we'll get you through it. Have a great day.